So I want to ask you a few questions. At first, you love questions. I know that. Who heard about CQRS before this presentation? Okay, a lot of people. Good, good, good. And who used it? Who used it in some form on a project? All right, so there will be some questions from you guys, I believe, and you will tell me if what we actually used in our project and what I described was CQRS or was it something a bit different. So let's go to it. At first, we will talk a little bit about how our standard systems work. Of course, all our systems are a little bit different than the others, but there are some generalizations that I will very bravely do. Then I will talk about loyalty system that we developed for Fashion Digital, or better to say for Peek and Kloppenburg. I was there on a project for 3 years, and I learned a ton there. And then we will talk a little bit about the CQRS, what it means, how we kind of use it, or what I think what it is, and you can tell me what you think what it is. So let's go there. So our standard system, trademark, is we've got some processing units, processing program, whatever. We've got some database, and we've got our clients, which are the most important part because that's what we do all this beautiful stuff. And the most systems are kind of designed as CRUD machines, CRUD, as we are creating some data, we are updating the data, we're deleting the data, and well, we are kind of processing these changes, and I intentionally put it into one box. And then I'm creating some kind of vocabulary because these actions that are changing data, I will call them commands. And then those commands are executed and kind of, well, the result of the commands are stored in the database. And then when the clients want to see what's going on with our data, they kind of ask our program again. We query the database and we got the model back to clients. That's pretty much what I did a lot of times. We are creating customers. Customer is logging in. We provide the customer with some information about his account, whatever. Very good idea to stay hydrated. So this is kind of what we do, or what I did a lot. Don't know what you did. So with standard systems, we've got these models for changes, quite similar to the model that we are returning back as reads, as for query model. And typically for the systems, there are less writes than reads. It kind of depends, but successful systems has often a lot more reads than writes, and in that scenario we can talk. We can think about the performance, whether the part of our systems that are handling the writes or the commands needs to be a bit smaller than the part that handles the reads. But that's for us to decide, of course. And this is kind of like the most of the use cases that we see in the system as in the real world. But of course, there is it is like, let's say 90% of use cases, but we got these 10% that we want to approach a bit differently, and at least from this list. We would approach the solution differently when the command model is quite different for query model. If there is just a little bit different, then it's not like much use to add a lot of complexity and to do something differently, less intuitively. It is actually creating some complexity in our systems, which is not always the best call. And then we also have systems when the writes are really just the minority and the reads are all the time. So this is, again, this performance issue that I kind of talked about when I was here, that if we write just a little bit, then the writing process can have just a little bit of resources that we have. And if we provide a lot of data, we can focus on this provision side. So yeah, let's have a look at our loyalty system. So what's up with the loyalty system? We all have some kind of cards, be it virtual card or haptic card, and you buy something, and the cashier will ask you, do you have our card? And you are proud that, yes, I do have. So you just put it in. And we do something very similar for the Big and Kloppenburg. It's a shop for clothes, for fashion. So you will be a customer. You are collecting bonus points. Bonus points, they are just numbers, just the integer, and you have some amount of it. You are getting it for the transactions. We've got some process in there, because you get the 20 bonus points for the t-shirt you bought, but you don't like it and you return it. Then I have to take the transaction and figure out, all right, you got these 20 points, but now I got to subtract it and all of that. I mean, normal programming. And then we've got bonus, like twice, 3 times a year. We take your bonus points, we change it into euros or Czech crowns or whatever. Actually, we are running the loyalty, well, not I personally, but Pick and Kloppenburg in Czech Republic has this insider program already on. So yeah, good for you. And then, as I mentioned, twice, 3 times a year, we take the bonus points, we change it to bonus, something that you can actually pay in the shop. And if you are a very good customer, which means that you are spending a lot of money on on your clothes, on the fashion, then you can be not just the basic customer, let's say, but you can be silver, gold, and whatever. You can be a very good customer. So this is kind of a business of our loyalty systems. And yeah, I mean, it kind of makes sense, at least for me it did. And yeah, the next thing is that our input will be just the raw transactions from the cashier. What happens on the cash desk? We will get this transaction from some subsystem, which is outside of our control, our expertise. There is another team that is handling it, and they basically can just push to us the transactions, no filtering, nothing fancy around. Just we have this data, we can send it to you. It was even in some VSDL at the beginning. It is Kafka now, but it wasn't too nice. Then we ask about what kind of data they can provide us, and they were like, yeah, we can't do really too much about this data that we have, but you can tell us that you want us to send you data from 4th of September to 19th of September or something like that. This filter had work, and we kind of okay. And then if we will miss some kind of processing, of course, we've got some outages or whatever. We've got a live system, so it crashes. So we can just ask, please send us this data again. We will catch it for real this time, and we can process further. And yeah, we did. Well, this is what I did for 3 years, actually. Of course, non-trivial aggregations, connection between the transactions, and non-trivial. I would say that it can take even a while, and this is kind of the setting of the system. This is what we are doing. So Of course, we went for microservices. I wasn't there for setting up the architecture. I came to something like this. Of course, this is a simplistic view, but we've got subsystem that is feeding our loyalty system, this whole thing, transactions. We've got something called transaction service that is creating aggregations of the transactions, and it creates the inputs for the status service that decides whether you are basic, silver, golden customer, whatever, and bonus service that counts your bonus points. Of course, status service and bonus service were talking to each other, because if you are a golden customer, you earn points in higher rate than when you are basic or something like that. So this is kind of the logic of our loyalty system. And then we got clients, and it really doesn't matter. It was like analytics or help desk or whatever. They want some data. This customer, what bonus do they have? What status? What transactions? So those were questions that we need to answer. And at the beginning, we got just a big transaction with all kinds of data, not just related to our loyalty system, but to the transaction in general, as what kind of clothes and all of that, which we didn't have a need for, but we got all of that. So this is definition that I got. CQRS is segregation between kind of processing of commands of the actions that are changing the data, and queries, that the process of retrieval of data. So this is a bit of written word, but yeah, it is architectural pattern. It affects the whole environment that you are developing for. Separates the responsibility of handling commands, modification of data from queries. This is just how we read the data. In a CQRS, the write model for commands and the read model are decoupled, allowing each to be optimized independently. So there is this division. And what it kind of meant for us, it was like, we want to have these transactions because this is pretty much what we have in, what we get in. But we don't necessarily need all of that information, but we don't want to miss anything either, because we need to analyze, debug all of that. We were thinking, we will get the transactions into our systems, and we will just save them as they are. The rawest, we got them. We had some very basic validations for something like identificator or something like that. But we thought we can just put all the data that our server is getting into some kind of big and stupid storage. In our case, it was just a separate table in the database, but you can have separate database just for that. It is just the implementation detail. So what we actually did is that this applies for every service that I showed you before. So status service, transaction service, bonus service, they all have similar architecture on their own, and that's what they kind of looked like. So again, this is SAP that are pushing transactions to our service, and we just very light reading. This is something that I can somehow categorize, or I at least think so. And then we just encrypted it and put it into, in our case, the table. database table, but this database table was our source of truth or point of truth. Well, never mind. And then we've got processes that were reading this table. They encrypted the records, and here we did all the heavy lifting, all the real validations and aggregations and all of that. So we know that the customer bought something and they deserve some points and status, all of that. And we divided it. Aggregate, also divide. I mean, this is just kind of processing, and we write it into the database. We had some tables even called read models, but this doesn't matter. This was just, this is the format of data that our clients are expecting. So we just put it into, some we put into databases, some just went to Kafka, but it doesn't really matter. It was just in the format, in the model that were actually useful for our clients. So if any client came to us, hey, I want information about this person, we weren't aggregated on the spots. We just had the information already, and we just send the result. So it was kind of divided. This is just like reading. We store it, then we process it, and after that we've got prepared the result for our clients. So what are implications of our system actually? We were streaming a lot. We weren't working on REST API or something like clients always asking us. We had REST API, of course we had, but this information from the transaction, they're propagated through our services as events, not as some kind of calls, not synchronous. So we also had this way of event sourcing. We got transactions for the customer in our database, and we were thinking like, okay, we mess up. And we're programmers. I mean, I don't know about you, but I mess up a lot. And we got a bug. So we created some invalid data. So what to do? And we always had this source of truth, these transactions. So we can just play with the offsets and let our process do processing again with our fix. And then we had something correct, and we were continuing on. Of course, what I mentioned, and I hope it was implicit, there is eventual consistency. I think we were kind of maybe lucky, or the business is like that when you buy your t-shirts, you don't need to have the points next minute or something. This is not bank system or something more serious. This is just selling clothes. So it is all right if it takes like hour or whatever, which is a lot, and this would be error on our side, some kind of alert. But it wouldn't be disastrous for the business, for the system. It would be still kind of reasonable for us. And but exactly because we wanted to be able to recreate all our states, all our data, we needed to work idempotentically. So if we get the transaction again in and it was already processed, we didn't want to make changes to our data. So that's what we actually, that's implication that we got. And those are specifics. I started to write like challenges, what was kind of hard around it, but then I kind of remember that's all right. It is complexity as some kind of challenge, but we got some something for free, something. This architectural pattern is also usable in a way that helps us to analyze it, debug. So this is specifics of the system. Something that I read from Martin Fowler or someone very smart like that. Smart people don't like complexity, and this is introducing more of complexity to the system, of course. But if the value that we are getting is interesting, is important, then complexity it is. We needed to be kind of like disciplined when working with the models. Sometimes it is tempting to reuse not the right one, and it kind of works for a minute, but it is slippery slope. So we need to be a little bit cautious about that. Then we needed to have, we got this read model process that was reading from our database and creating new records. So we needed to monitor it. We need to know what is it doing, and it might be challenge. And also implement our methods, our processing to be important also isn't the simplest thing ever. So the other thing that we got is that we always had the raw data accessible. We didn't need to ping our sub team all the time that what was the data for this between these dates or whatever. We always had the data at hand, and we were able to debug and analyze and do all kind of stuff because we had always the data in our services. This backfired a little bit because no one was doing it like our team was. So we ended up as owners of a transaction data, even though it wasn't our responsibility. But of course, we were good, so we were responsible. And this is something library for streaming. This has to do with the range of the size of the project, because as you saw, we got multiple services. And after a while, we saw the pattern that we are reading something and we are doing some processing, but we are doing it in all our services again and again. So we just created a library. There is, you will have library, you will get versions and all of that jazz, but we've got the standard way of dealing with these streams. And when we wanted to improve something, we can improve it at one place and then just deploy. So that worked well for us. So these are my sources. Actually, I didn't read whole too much. You just saw that I explained what I did last 3 years. So I guess this is what I get the most knowledge and most of what I told you from. But I like Martin Fowler, so I read a bit from him, and that's pretty much what you can do as well. I mean, those articles aren't even that long. So thank you.